Next parameter is about RMS value of load current, that is IRMS. So before starting out with the actual value of IRMS, let us discuss what is RMS in basic first. RMS refers to root mean square. So if you are supposed to find the RMS value for a particular parameter, you have to take a square of the signal first, then take the mean and then take a square root. So this is the order to find out the value of RMS, which is root mean square. Now let us calculate the value of IRMS, which is nothing but square root of 1 by 2 pi integral 0 to pi Im sin omega t square d omega t. So as I said before, first we are calculating the value for current, that is the RMS for the current. So we have to take a squared value of current first. So the squared value of load current is Im sin omega t square. Then you have to take the mean value. So it is integral of 0 to pi divided by 2 pi, and third thing is you have to take square root. So we have a square root over here. Now let us calculate to find the actual value, which is square root of 1 by 2 pi integral 0 to pi Im square sin omega t square d of omega t. So here we can take the Im square, which is out of the integration range because it is a constant value. So you can take that, and we have a square root also. So after taking square root, we can simply write it as Im into square root of 1 by 2 pi integral 0 to pi. For sine square, we can write it as 1 minus cos 2 omega t divided by 2 into d omega t. So now we have to split up these two terms and integrate it separately to get the actual value of IRMS. So IRMS is equal to Im into square root of 1 by 2 pi. So integrating the first term, we will get it as omega t by 2 minus the second term, we will get it as sine 2 omega t divided by 4, and the range of integration will be from 0 to pi. Solving this further, we will get Im square root of 1 by 2 pi. Simplifying this, that is after applying upper limit minus lower limit, we will simply get it as pi divided by 2. So this will be simply equal to Im divided by 2. So here we have to know a small thing, that is the root mean square of half wave rectifier is equal to Im by 2. Whereas if you consider for full wave rectifier, the same IRMS will be equal to Im divided by root 2. So this is for full wave rectifier. So the questions will be with a twist in this condition only. So in case if you have any question where you are supposed to calculate the value of IRMS, the question will be like calculate the IRMS value. But you have to make sure that you are checking it for either it is half wave or a full wave. So for half wave it is Im by 2, and for full wave it is Im by root 2. So this is the basic difference. So when we see about the full wave rectifier, we will calculate the IRMS value again there also. But here I am just telling you to know the difference for half wave rectifier and full wave rectifier in terms of IRMS value. Next is DC power output PDC. So it is nothing but product of, usually power is nothing but a product of voltage and current. So it is E into I. In terms of DC, so it is EDC into IDC. Again you can represent E in terms of I into R. So it will be I squared R after multiplying with IDC over here. So IDC square into RL. So we have calculated the value of IDC just before. So we can apply the value of IDC, which is nothing but Im divided by pi the whole square into RL. So which is Im square divided by pi square into RL. Again the value of Im is a question mark there. So Im, which is nothing but ESM divided by the total resistance value RF plus RL plus RS. So applying that, we will get the net DC power output PDC as ESM square RL divided by pi square into RF plus RL plus R. the whole square. So this is the net value of DC power output. Likewise, we can calculate the AC power input also. So the AC power input is nothing but the power input from secondary of transformer, which is applied to load resistance, forward resistance and source resistance. So PAC will be equal to IRMS square into RL plus RF plus RS. So here we know the value for IRMS, which we have calculated just now. Applying that, we will get it as Im square by 4, because the value of IRMS is nothing but Im divided by 2. Applying that, we will get it as Im squared by 4 into RL plus RF plus RS. So this is the value of AC power input PAC. Next is rectifier efficiency eta, which is nothing but ratio of output DC power to input AC power. So we have calculated the output DC power separately and input AC power separately. So now let us apply the value of DC output power and AC input power and calculate its ratio to get the rectifier efficiency, which is PDC divided by PAC. So the value of PDC is into RL divided by the value of PAC is Im square divided by 4 into RF plus RL plus RS. So simplifying this, we will get it as 4 by pi square into RL divided by the total resistance, which is RF plus RL plus RS, which is further equal to, after substituting for the value of 4 by pi square, we will get it as 0.406 divided by 1 plus RF plus RS divided by RL. So this is the net equation for rectifier efficiency eta. So this value, considering RF plus RS, which is very less than the load resistance RL, the percentage of maximum efficiency will be 0.406 into 100%, which is nothing but 40.6%. So this is the rectifier efficiency value. So in a half wave rectifier, the maximum 40.6% of AC power will be converted to DC power in load. So the remaining 60% of power, in the sense it will be a question mark. So this 60% of power will be converted as ripples in output, which is nothing but the fluctuating component. So this is the maximum rectifier efficiency, which is 40.6. So we have to remember this value, because sometimes questions can arise from this particular data also. So the half wave rectifier will have an efficiency of 40.6%.